Enterprise AI starts with knowing who or what is requesting access. In this section, we'll connect SSO, MFA, passwordless authentication, and federation to one goal: reducing credential risk while enabling secure access across apps, APIs, and cloud workloads. So far, we've established the identity foundation: users, services, workloads, agents, trust boundaries, least privilege, and governance. Now we move to authentication, the proof step. Before authorization, agent permissions or secrets access can be trusted. Each identity must first prove it is who or what it claims to be. Authentication in enterprise AI is not limited to employees signing into business apps. Admins, developers, APIs, service accounts, agents, and workloads all need to prove who they are. That check happens before high-value actions like submitting prompts, invoking models, accessing datasets, or running tools. If authentication is weak, attackers can take over accounts, abuse models, or extract data. Strong programs centralize authentication through IAM, apply consistent policy, and make every event observable. Single sign-on makes the enterprise identity provider the control point for AI access. A user signs in once through Entra ID, Okta, Ping, or Google Cloud Identity, and that trusted session is used across AI apps, admin consoles, SaaS tools, and internal gateways. This reduces password sprawl and blocks unmanaged local accounts. It also ensures that MFA, device trust, conditional access, and session controls follow the user everywhere, improving auditability and speeding offboarding. When a user opens an AI application, the app should not handle passwords directly. Instead, it redirects the user to the identity provider, where MFA, device checks, and conditional access are enforced. If authentication succeeds, the IDP returns a signed token or assertion using SAML, OAuth2, or OpenID Connect. The AI app then validates that token, creates a time-limited session, and rejects unsigned or untrusted claims. MFA protects AI systems by requiring proof beyond a stolen password. That proof might be a trusted device, biometric, security key, or passkey. It matters most for admins, developers, and data scientists who can reach prompts, datasets, models, and orchestration tools. But not all MFA is equally strong. SMS and simple push approvals can still be phished or abused through fatigue attacks. Prefer phishing-resistant options like FIDO 2 keys and passkeys, reinforced with monitoring, conditional access, and least privilege. Passwordless does not mean weaker authentication. It means moving away from reusable secrets that can be stolen, guessed, or typed into a fake login page. With passkeys, the service sends a challenge, and the user's device proves possession of a protected private key. Biometrics or a security key unlock that proof locally. For AI systems, start with privileged users, administrators, developers, and sensitive data workflows, where phishing-resistant access matters most. Conditional access turns login into a risk decision, not a simple password check. Each request is evaluated against signals such as user risk, device health, location, behavior, IP reputation, and the sensitivity of the target resource. Low-risk access can proceed normally. Suspicious activity may require step-up MFA. Higher risk can limit the session or block it entirely. For AI platforms, combine identity provider risk signals with application telemetry from consoles, model APIs, and datasets. Think of Auth2 as delegated permission. A user allows an app to call an API, but only within approved scopes carried in an access token. OpenID Connect builds on Auth2 by adding proof of who the user is through an ID token with identity claims. In AI systems, these tokens can control access to models, RAG services, vector stores, and internal tools. Validation is critical. Issuer, audience, expiry, signature, and scopes must all be checked. In the authorization code flow, the AI app does not receive tokens through the browser redirect. It sends the user to the identity provider for sign-in, MFA, consent, or policy checks. The provider returns only a short-lived authorization code. The app then exchanges that code for tokens over a protected back channel. PKC ties the original request to that exchange, protecting public clients. Finally, keep tokens out of prompts, logs, client-side code, and browser storage. Tokens are signed security messages with different jobs. An ID token tells the application who the user is. An access token tells an API what that user or workload can do. Scopes request permissions, while claims assert identity, roles, tenant, or entitlement details. Refresh tokens keep sessions alive, so they need strong protection. Short lifetimes, rotation, secure storage, and revocation when risk changes. In AI platforms, overly broad tokens can expose powerful tools. Federation lets one trusted identity system support access across many AI environments, without creating duplicate accounts everywhere. A corporate identity provider authenticates the user, then passes verified claims to SaaS AI tools, internal gateways, cloud workloads, or partner tenants. Standards like SAML, OAuth 2, OpenID Connect, and Cloud Federation carry that trust. The key control is mapping claims to the right roles and entitlements, while limiting partner or vendor trust, so access does not expand unexpectedly. Federation changes shape depending on where AI runs. For SaaS AI, the priority is connecting the product to the enterprise identity provider, so SSO, provisioning, and access policy stay centralized. For cloud workloads, Federation should replace static cloud keys with short-lived workload identities. For internal gateways, the gateway becomes the broker, authenticating callers, exchanging tokens, mapping policy, and auditing access across model providers, tenants, and residency boundaries. A strong authentication architecture starts with a single enterprise identity provider, not separate login silos for each AI tool. Place phishing-resistant MFA or passwordless access in front of sensitive workflows, especially administration and model operations. Use OAuth 2 and OIDC carefully. Validate tokens, keep them short-lived, and limit scopes. Federation should be intentional, monitored, reviewed, and automatically deprovisioned. The result is consistent access control across apps, consoles, developer tools, APIs, and machine identities. Authentication is the front door for secure AI. Centralized SSO, strong MFA, passwordless sign-in, Auth 2 or IDC, and Federation create trustworthy identity signals for users, admins, apps, and workloads. Those signals only become useful when they are mapped to permissions. Next, we turn to authorization with RBAC, ABAC, and PBAC.